Hey dudes and dudettes, welcome back. We've got one more question for the week. Happy Friday. This question will be the last question that is going to be focused on kinematics and forces. Everything from this point forward is going to be a review of the energy stuff that we're doing for e-learning. And I'm going to take one question each day for that. So if you've still got questions, we can do Google Hangout sessions, which will essentially function as tutoring, where you can see like what's on my screen, and we can continue to go through it. Otherwise, I hope you guys are navigating this whole e-learning thing. And all right, let's get to it. All right, so for this question, Ramsey slides a 0.6 kilogram book, initially moving at 7.2 meters per second after leaving his hand. The book travels 11 meters before coming to a rest, and we're being asked to calculate the coefficient of friction. So the first thing we're going to want to do is we're going to want to list our knowns. So we list out initial velocity, final velocity, acceleration, time, and displacement. And we're going to make our force diagram and our net force equations. Since it's sliding across the ground, we're probably not going to have to deal with sum of forces in the y direction, so I just listed x. All right, so first thing we got to do, our force diagram. So we're going to have Fg going down. Boom, shakalaka. We've got Fn going up. And since this is after leaving his hand, the only thing that is going to be affecting this book is going to be the force of friction. And let's say Ramsey's throwing it to the right. Friction is going to be resisting that, and it's going to be going to the left. So we'll say this is force friction, and since it's moving, it's going to be kinetic, okay? It's 0.6 kilograms, so what we'll do is we'll take 0.6 multiplied by 9.8, and that gives us 5.88. Okay, so Fg is going to be 5.88 newtons. Fn is going to be 5.88 newtons. Okay, so now we've got to determine what our force friction kinetic is. Doesn't tell us that, but the way we'll be able to solve that is since there's only one force in the x direction, that is going to be our net force. Okay, so we'll be able to solve that with mass times acceleration. So this is just going to be FFK. But now we've got to find our acceleration. We have our mass, which is 0.6, but we're going to have to find acceleration using our kinematics. So it says it's initially moving at 7.2 meters per second. So 7.2 meters per second. The book travels 11 meters before coming to a rest. So our V final is 0 meters per second. Acceleration is what we got to solve for. It does not say the time. Okay, so this is not something that we know. So we can put NA, not applicable. And it travels 11 meters. So that's our displacement. So we've got to pick what kinematic equation we need to use that does not involve time and solve for A. So if we look at our kinematics, okay, this is the equation that we're going to need. V final squared equals V initial squared plus 2A multiplied by displacement. So if we were to put our numbers in there, our V final is 0 because it's 0 squared equals 7.2 squared, which is 51.84 plus 2A times 11 meters. Put that in there. And if we were to work that out using math magic, it's going to be, this is going to have to be negative. Well, we're going to move this over. So 51.84 is going to move over to the other side. So since this is technically addition, you move that over. So it's negative 51.84. So you're moving that over there because it's reverse order of ops. 2 times 11 is 22A. So it's going to be negative 51.84 equals 22A. So divide this by 22. Boom. Equals negative 2.36 meters per second squared. Okay, so we've got our acceleration now. So it's going to be negative 2.36 meters per second squared. We plug that in down here, so we've got 0.6, okay, which was our mass, multiplied by negative 2.36 meters per second squared. So we'll do that real quick. So we've got 0.6 multiplied by negative 2.36 equals 1.416 negative. So it's going in the negative direction, so we know that. So I'm just going to use the magnitude, 1.416. So FFK in this case, because it's the only thing on our net force equation in the x direction, is 1.416. Okay. So the last thing that we've got to do, because we've got to calculate the coefficient of friction, we plug it into our mu k equation. So we've got Fn multiplied by mu k, because it's moving, equals force friction kinetic. Okay, we've got two of these things. Fn is 5.88. 5.88 newtons multiplied by mu k equals our force friction, which we calculated was 1.416 newtons. Okay, we've got to isolate this. Okay, so we'll take this, the 5.88, divide that right there, divided by 5.88 newtons. Get rid of that. So we'll do some math. 1.416 divided by 5.88. That gives us our coefficient of kinetic friction. So our mu k equals 0.241. There we go. So the one thing that people get tripped up on is making sure that you don't have a force going to the right. So the key for that in the word problem is going to be after leaving his hand. I went ahead and underlined it. It won't be underlined usually on the test, so you've got to be able to figure that out. So Ramsey is no longer like putting any force onto it. It's after it's left his hand. So the only force that's acting on this book is the friction that's resisting it. What up, Ramsey? What up, guys? You have any questions, let me know. Yeah, have a great weekend. I know every day feels like a quasi weekend here, but I hope you guys are doing all right. We miss you. See ya.